while I'm just getting the attendance in, I want you guys to write these two problems down, okay? And because this is what you're going to be evaluating. Like I said, nothing new today. We're going to catch up. I want to just review some things. Yep, we're going to do this together, and then I'm going to give you some questions like this. So this is your time. You aren't, but other people are. So here we are. Find the square root. Leave fractions as fractions, decimals as decimals. Now here's the whole thing. You guys got calculators. If it's a decimal, use your calculator. Okay? If it's a whole number, use a calculator. You should be able to recognize it. I mean, so in this particular case, now you could do this because I know the square root of 36 is 6. Put the square root of decimal 36. 0.6. Use that calculator to do it, or you do that. Correct? Okay. In this case, though, when it's a fraction, we leave fractions as fractions. So this, I don't need a calculator for this. I do the square root of the top. 49 square root is 7. 81 is 5. Good. Okay. Then, are the following perfect or non-perfect squares? Why? Remember something. I'm going to pause while you try those out, and then we'll take them up in a few minutes. Okay? Now, perfect or non-perfect, I don't know if you remember this from the other day when we took this up. You know something's a non-perfect square if you put it in your calculator and you get a decimal that doesn't end, terminate, or it doesn't repeat. Put 12 out of 27 in for a square root. It might be a perfect square. Well, it depends on your brand of calculator. I'm going to just bring my calculator up. Most work this way, but there's some that don't. Okay, I'll bring mine up. Just move this recording button here. And let me see here. It feels small. I'm going to clear it. Boom. And how do I put 12 out of 27 into this? My calculator runs a little different, but you're going to hit the square root button first. So I hit the square root. You guys do too. Let's do this together. Bracket. Then I start a bracket, because I'm going to put the fraction in as a division column. 12 divided by 27. Every fraction is a division column. You guys see what I did? Square root button on my calculator, bracket, 12 divided by 27, and the bracket, so that the whole thing is under the square root symbol. I'm going to hit it, and I'm going to get decimal 6 repeated. Yeah, I do. Okay. What's that? Then I'm going to come around and check why you did, because you should have 0.666 and then somewhere it cuts off.
I don't have a 7.
Okay, close to that. That's because you didn't use the bracket. The bracket, let's try that. Yep, that's the bracket. Really important to both under. There's a sweet treat, man. Okay, so looking around at other people's stuff. A lot of people don't have the 666. Mine rounded up at the very end. 0.6666. You get the idea. It's repeating forever. Now, if it's a non-perfect square, if it isn't perfect, it will not repeat and it won't end. This is definitely a repeating one, right? It's actually 2/3. And I know how I could get that to 2/3. You don't know. So I'm going to put in here equals 0.6. I'm going to just put the line on there. You guys have used the line before to mean 6 forever, right? 6, 6, 6, 6, 6, 6, 6, 6, 6. Okay, anyways. So is this perfect or non-perfect? This is perfect. Well, because it's repeating decimal. I can show you how it is. It didn't ask you to solve for it. I can show you how it is. Did you ask? I was going to show you. Now, what I'm doing in the color here is not necessary, but it answers Rami's question. How's that perfect? Well, you guys agree that 12 is 4 times 3? And that 27 is 9 times 3? The reason why I'm doing this is within that fraction, you can divide the top and bottom by 3, can you? Right? Inside the root sign. I'm going to just do that. Divide out the 3's. And I've got root of 4 over root of 9. And those are 2 perfect squares, aren't they? That's 2 out of 3, which is decimal 6 repeated. All I needed to know to answer this question is perfect or non-perfect, though. So I just put it in my calculator and notice 6 repeating. Yeah. To actually solve it, that's how you could do it. But I'm not asking you to do that one with reduction inside the root. Yeah, that's a grade 11-ish. What's that? No, that's why I put it in a different color. Green is what you guys need. 2.6. If I put this in my root sign, no brackets needed because it's just one number. Does that look like it's going to? No, that's a mess of digits, right? It's not repeating. Not like 77 or 72, 72, 72 or something. So I'm going to say, sure, it's 1.6, 1, 2, 4, 5, blah, blah, blah. Not repeating, so it's non-perfect. Why? Because it's not repeating. I think you could do the last one without a calculator. Okay. Yeah. So this is perfect. Why is it perfect though? The reason I'm going to give a mark for why. In this case, the decimal cuts off. It's 5.0 and you don't even need it, right? Terminating or decimal stops. You don't have to use the word terminating. Okay. So when I ask you a question like that, that's what you're after. Yeah. I'm going to skip this third one right now. And I'm going to put down a question here. Here's what I'm going to put down. Calculate the number whose square root is. Let's start with an easy one. So when I say this, calculate the number whose square root is 3, I think, and I'm going to put it in blue because you don't have to cut. I think the square root of what equals 3? You guys follow what we're saying? Now you know the answer. What's the square root the opposite of? Just like multiplications and division are opposites, it's squaring. So if you want to find out what number was underneath that square sign, 9. You say, oh, 3 squared. And so I'm going to write down, and I'll do this in green, square root of 9, right? That one's, I was started out simple, so you can do it in your head. Not that this is any simpler because the calculator works just fine. How about the number whose square root is, give me a single digit that's not 0. 7? 2.7. How would I find that out then? Square, right? You need a calculator, so I'm going to go 2.7 times 2.7, or I can hit the square. 7.29. Right? So I square it. If I'm not sure about that, I can check my answer. Square root of 7.29. Oh, it's 2.7. I designed it. So it should be a fraction. Actually, give me one number that's not 0, not 1. 3. A non-zero, non-1 number. Someone on this side of the class. Unlucky number what? 7 again. That is terrible. Perfect. Perfect choice. Well, this is the square root of, well, 3 times 3. 49. You squared the top, you squared the bottom. Great. Oh, that's awesome. That's what I want you to do, pardon me, on the hand-in test. Yeah. That's exactly what I went over. You know what? I'd say do the hand-in first.